Remember when Voyager 1 launched back in 1977? Just a little spacecraft carrying a golden record filled with Earth's greetings, sounds of nature, and hopes for cosmic contact. It was supposed to be a quiet messenger, drifting silently beyond the planets into the eternal emptiness of space. Now, 45 years later, Voyager 1 is over 14 billion miles away, far beyond the heliopause, in what scientists believed was interstellar nothingness. But Voyager has just shattered that assumption. After months of silence and garbled data, it has sent back a signal so strange, so precise, and so unexplainable that a Nobel Prize-winning physicist has broken ranks with conventional science to say, Voyager 1 may have reached a boundary beyond our reality. In late 2024, mission engineers were growing concerned. Voyager 1's data had become jumbled, static-filled, indecipherable. It was expected because the craft is ancient, battered by cosmic rays, and its systems are way past their design life. But then, in early 2025, something happened. The static cleared. A burst of coherent, rhythmic data came through, cleaner than expected, eerily structured. But the content was impossible. Plasma densities were far above normal. Gravitational tugs shifted the craft's trajectory, and magnetic field patterns were never observed before. There was a rhythmic pulse that seemed to respond to Voyager's own transmissions. Just like that, what began as a maintenance routine turned into a scientific crisis. Struggling to make sense of the data, scientists reviewed all known models. Nothing fit. One team initially assumed an onboard malfunction, but Voyager 1's instruments passed every test. That left only one conclusion. The anomaly wasn't with the spacecraft, it was out there. A Nobel-winning physicist, who had worked on early interstellar models, reviewed the findings and issued a warning. Voyager 1 may have encountered a domain of space where classical physics breaks down. We are possibly witnessing the transition into a space that obeys new rules we've never seen before. He laid out three terrifying possibilities: the edge of a multiverse, a bubble boundary where our universe ends and another begins, different laws, different time flow, perhaps even intelligent observation. The boundary of a simulation. If the universe is a construct, as some quantum theorists have long suspected, Voyager may have bumped into the code, the edge of rendered space. A cosmic construct, something built, intentionally or not, by forces or intelligence beyond comprehension. Not a planet, not a star, not even a black hole. Something else. The transmission logs show patterns that no one can yet explain. Particle densities spiking every 137 seconds, regular, unnaturally stable. Magnetic fields that shift in perfect geometric symmetry, unlike any known wave interference. Plasma echoes that seem to mirror Voyager's own emissions, like sonar in reverse. A pulse train, described by mission engineers as structured, possibly reactive. It's as if the universe answered back. Even NASA has cautiously acknowledged the strangeness. One mission lead said, "We've entered a data regime we cannot yet model. Voyager may be detecting something fundamentally new." This isn't just fringe speculation. Experts from Caltech, the University of Tokyo, and CERN have reviewed preliminary findings. A group of physicists published a preprint paper warning that Voyager's readings are inconsistent with existing interstellar field theory. The Nobel laureate in question, whose identity is withheld pending peer review, confirmed the data appears intentional or responsive. Even conservative voices in astrophysics have conceded either we're seeing physics fail or we've just seen it evolve. Voyager 1 has limited power left. By 2026, most of its systems will begin shutting down. The window to study these transmissions is painfully short. Scientists are now rushing to cross-check with Voyager 2, which is on a different path. Use Earth-based instruments to scan the same region of space. Design data compression techniques to squeeze more transmissions out of the dying probe. This may be the only time humanity gets a direct signal from beyond known physics. And if it is, what we do with it matters more than ever. If you've ever looked up at the night sky and wondered what's really out there, this is your moment. This isn't about telescopes or textbooks anymore. This is about us, the species that sent a message to the stars and may now be getting a reply. Voyager 1 was built before smartphones, before the internet, before most of us were born. And yet, it may be the first thing to tell us the truth about the nature of the cosmos. Are we alone? Are we being observed? Is the universe just one of many? These aren't science fiction questions anymore. They're diagnostics coming from a probe we made with parts older than your microwave. Voyager 1, humanity's furthest messenger, has pierced into something no one predicted. The rules are different there. The laws, unwritten. And maybe someone or something is waiting. This isn't about panic. It's about possibility. Not fear, but wonder. You've seen the data. You've heard the warnings. Now ask yourself, if Voyager found the edge of reality, what's on the other side? Because the universe just blinked back, and it's time we looked again. Launched in 1977, Voyager 1 has traveled farther than any human-made object in history. But it wasn't distance that made headlines in 2025. It was what it found at the very edge of the solar system, the heliopause. What should have been a quiet, fading boundary turned out to be something else entirely. Turbulent and erratic plasma spikes. Radiation bursts that danced in patterns. Structured fluctuations in particle density, like waves beating against a shoreline. Rather than slipping peacefully into interstellar space, Voyager 1 reported a chaotic region, as if the solar system is wrapped not in a bubble, but in a storm. The heliosphere is supposed to be our shield, a bubble of solar wind protecting us from the harshest galactic radiation. But Voyager 1's data hinted at something terrifying. The heliosphere may be collapsing. That turbulent storm at the edge wasn't just noise, it might be a compression of solar plasma, losing strength. Voyager's cosmic ray subsystem detected surging galactic particles, no longer deflected. Some readings showed pressure levels 3 times higher than predicted. Then, in February 2025, NASA quietly shut down Voyager 1's cosmic ray detector to conserve its dwindling nuclear power. But before it went silent, it had already delivered its final warning. As if the plasma chaos weren't enough, something even more disturbing emerged. Voyager 1's path, calculated and recorrected for decades, began to drift. Not by error, but by an external gravitational force. A pull, a slow, steady tug. NASA checked and rechecked. There were no nearby stars, planets, or known celestial bodies. Yet the force persisted. It was consistent, measurable, and completely unaccounted for. Even Earth's most advanced observatories scanned the region. No light, no mass, no heat. Just a gravitational pull from an invisible source. Scientists are now calling it a dark mass anomaly, a placeholder term for something that shouldn't be there, but very much is. For decades, physics has followed models that predicted what Voyager 1 would see. But those models are now in crisis. What Voyager 1 revealed forces scientists to ask, is the heliosphere not as protective as we thought? Is interstellar space far more structured and hostile than we believed? What is this invisible gravitational anomaly, and could it affect us? This isn't just about space. This is about our place in it. The reaction within the space community has been nothing short of seismic. NASA teams, usually cautious with words, privately referred to the readings as deeply concerning. A former JPL engineer was quoted saying, "We have never seen anything like this. It rewrites everything we thought we knew." Independent astrophysicists now speculate this anomaly could be a new kind of mass structure, or worse, a relic from a previous cosmic event interacting with our system. Even science journals are moving away from certainty. Papers now use phrases like unprecedented turbulence, data mismatch, and mass anomaly with no light signature. The implications go far beyond Voyager. If these findings are accurate, they mean the edge of our solar system is not peaceful, but hostile and shifting. Our current models of the heliosphere may be obsolete. There may be massive, invisible objects in interstellar space capable of exerting gravitational force without emitting detectable light or energy. And if these invisible masses exist near us, what else might be out there? This discovery reopens a door many thought closed. Could we be missing a fundamental piece of the universe? Some theorists are already connecting Voyager 1's data with dark matter concentrations, gravitational wave interference, even alternate dimensional structures bend in local space-time. The mystery force Voyager encountered is real. It's just not visible, not understood, not predicted, and that alone makes it one of the greatest cosmic enigmas of our time. If Voyager 1's data is dismissed or underestimated, we risk leaving Earth unprepared for future cosmic radiation events, blindness to gravitational disturbances that could affect our probes, satellites, or even long-term solar stability. Missing a new chapter of physics, one that could unlock deeper truths about our universe. We can't afford to look away, because what lies beyond the heliopause isn't silence. It's something calling us to pay attention. If you're a dreamer, a skeptic, a believer in hidden truths, if you've always felt that space held more secrets than answers, then this moment is for you. Voyager 1 isn't just a probe. It's a messenger from a place humans may never reach. Its final whisper wasn't closure, it was invitation to question, to explore, to look again. As of now, Voyager 1 continues drifting, slowly, silently, with most instruments offline. It is, quite literally, sailing into the unknown. Its last active subsystem, the plasma wave instrument, still records faint echoes. Its trajectory is still shifting, ever so slightly. And its final message, this chaotic border, this invisible force, still haunts the minds of those listening. You've seen the journey. Now imagine what lies just beyond. Because if Voyager 1 taught us anything, it's that space isn't empty. It's waiting. Something unbelievable just happened. Voyager 1, the spacecraft launched in 1977, has broken its silence and sent back a signal so strange, so structured, and so downright chilling that one Nobel Prize-winning physicist called it impossible. This changes everything. Yes, after months of corrupted transmissions, the probe, over 14 billion miles away, has suddenly reawakened with clear, coherent data. But it's not just clarity that's causing a stir. It's what's in the data that's freaking everyone out. Voyager 1 isn't supposed to do this. The signal isn't just clear, it's rhythmic. It pulses in structured intervals, like a code. Scientists compared it to every known natural phenomenon: solar flares, gamma-ray bursts, magnetic waves, but nothing matches. A Nobel laureate who examined the data didn't mince words. This is non-random. This is intentional. Or it is something new we don't understand. The probe has also recorded plasma fluctuations that ripple in a pattern too perfect to be coincidence. Magnetic field shifts that contradict the expected uniformity of interstellar space. Sudden surges in particle density where there should be calm. Tiny gravitational anomalies that are nudging Voyager off course in subtle, unexplainable ways. It's not just weird, it's wrong, as in, it doesn't fit any current model of physics. What do you do when reality no longer follows its own rules? The physicist who received and studied Voyager's data believes the spacecraft may have entered a liminal region of space, a transitional zone beyond the heliopause, where our understanding of the cosmos ends. He suggested possibilities that sound like science fiction, but with the weight of scientific authority. A layered structure of space itself, like a cosmic membrane. A boundary to a larger reality, possibly a multiverse or simulated universe limit. A naturally occurring spatial construct we've never theorized or discovered. He was clear. This is no ordinary space. This is not just beyond the solar system. It is something else entirely. This is an existential event. Astrophysicists, cosmologists, and mathematicians from across the globe are stunned. The possibility that Voyager has reached a point where our laws of physics fall apart is profoundly unsettling. The scientific community isn't rejecting the data, it's rallying around it. Teams are reanalyzing deep space metrics. NASA's Jet Propulsion Lab has reportedly held closed-door briefings, and emergency meetings are being convened at observatories. For the first time in decades, science is facing the possibility that we may be wrong about space itself. Here's the truth: science thrives on the predictable. When something happens that can't be explained, it's not just inconvenient, it's terrifying. The Voyager data presents a problem with no playbook. No known particles can behave like this in interstellar space. No wave mechanics explain the rhythmic signal. No gravitational theory supports the subtle, repeating drift of Voyager's path. This isn't just a crack in the theory, it's a doorway to something unthinkable. What if our universe has zones? What if we just reached the cosmic version of the ocean's edge? The Nobel physicist isn't the only heavyweight weighing in. Veteran NASA scientists and pioneers of astrophysics are now revisiting decades-old theories about the nature of dark energy and dark matter, the fabric of space-time. The idea of a computational universe where Voyager may have reached a break in the simulation. Even MIT and Caltech researchers are rumored to be launching collaborative investigations into whether Voyager's anomaly matches patterns found in quantum entanglement or AI-generated randomness detection. As one physicist bluntly stated, if this is real, and it is, we have to rewrite the book, and possibly the shelf the book is on. Voyager 1 is aging. Its power is dwindling. Its instruments are decades old. Scientists estimate it has less than 3 to 5 years before it permanently falls silent. That means we only have a small window to gather more data. This could be our last chance to study a region no other spacecraft has reached. If the signal stops, we may lose this cosmic clue forever. And here's the kicker: no other probe will reach that distance for at least 20 more years. That's a generation lost if we don't act now. If you've ever looked at the night sky and felt something stir, something ancient, something infinite, then you already understand. Voyager 1 isn't just a machine, it's our messenger. Launched before most of us were born, it carries a golden record of Earth's music and languages, maps to our location, the hopes of an entire species trying to say, we were here, we mattered, and now it may be talking back, not to aliens, but to the universe itself. It's asking questions we forgot to ask, and whispering answers we barely understand. Of all the strange phenomena, one haunts researchers most: a pulse in the data, perfectly spaced, deliberate, not natural. Could it be a phenomenon we don't yet understand, like a spatial heartbeat? A communication, not necessarily from aliens, but from space itself. A natural feedback loop, where Voyager's signal is being echoed back. Nobody knows. And that's what makes it terrifyingly beautiful. It is not noise, it is pattern. And pattern means purpose. This isn't just Voyager 1's story. This is ours. The data it just sent isn't just about magnetic fields and plasma. It's about our relationship with reality, with truth, with the unknown. We've always looked up at the stars and wondered. Now, one machine, built by human hands, has touched something we never dreamed we'd reach. And it's speaking. The only question now is, will we listen before it falls silent again? This isn't a movie. This isn't science fiction. This is happening now. If you see yourself as someone who values truth, curiosity, and the infinite unknown, then this moment is yours to claim. Follow the updates, share the data, demand funding for continued deep space research. Keep this story alive, because it may be the first chapter of a new cosmic era. You've seen the edge of something vast. Now stand at that edge and look out.